Hey there, statisticians. So in this video, what I'm going to talk to you about is the probability of compound events, and we're going to focus on the word and. I'm going to look at event A and event B happening. I need both of them to happen to be considered a success. So what are my independent events? Two events are independent if one happens and it does not change the probability of the second one. So they have nothing to do with each other. Dependent events, however, the independent event will directly affect the dependent event. For instance, the number of hot dogs I buy and the cost. Alrighty, or picking a card out of a deck and then picking a second card without putting the card back because now there's less cards to pick from. Independent event would be I pick a card out of a deck and then I put it back and then I draw a second card. Alrighty, or independent events, I flip a coin and I pull out a rubber ball. Dependent events are I'm pulling stuff from the same pot without putting it back. All right, so for further questions, we'll do that in class. So like if we look at this, if I roll 2 dice, what is the probability that I will get a 5 on each dice? Or if I draw 2 cards from a well-shuffled deck without replacing the first card before the second card, what is the probability that both will be aces? So which of these is independent? Well, when I roll my dice, the first 5 never affects the second. The first roll doesn't affect the second roll. Dice do not have memory. All right, so I can roll the dice, and whatever I get has no effect on the second one. So that event would be independent. However, if I pull the cards out and I don't put it back, now there are only 51 cards in a deck. If you did not know, there are normally 52 cards in a deck. So when we are finding the probability of of independent events, and I need both of these events to happen to be considered a success, noted by the word and, we're going to multiply the individual probabilities together. So to find the probability of A and B, I'm going to do the probability of A times the probability of B. So we normally break this down. If I want the probability of A, we can say I need the probability of A times the probability of B given that A has already happened. Or it's the probability of A and B. What is the probability of A given that the probability times the probability of A if B has already happened? The second one has already occurred. That's the way we read that. Okay, here are my multiplication rules. So if I give you 2 independent events, they don't affect each other. The probability of A equals the probability of A given that B has already happened, then they are independent. So the probability of A and the probability of A given that B has already happened are the same number, then they're independent. When they are independent, I can multiply the individual probabilities together. And if A and B are dependent events, we would do this one. Alrighty? So, because remember, for B to happen, sorry, this is going to go. So if A's already happened, then B, the probability of B changes. Alrighty, so come in with your questions tomorrow, and I will be glad to answer them. We're going to hit out our work. We're going to do very well, and I will see you when I see you.